So this morning I sent out an announcement with a picture of the whiteboard of the upcoming dates, and I was just going to walk you through that real quick. So today we're going to start the linear versus nonlinear lesson. We're just going to be covering linear functions, linear graphs today. Wednesday we'll be doing the nonlinear side and then reviewing it all to get ready for the lab. Remember, for the linear versus nonlinear section, there is no test. There's just a lab. Okay, it's just one of those SLOs that we have to cover according to the state and to get ready for the final. So that's today and Wednesday. All right, so today it's the linear portion. Wednesday is the nonlinear portion, which won't take up a lot of time, and then we'll go over everything and get ready for the lab. And the lab won't be bad either. So Monday of next week is our last in-person class meeting. It's the last time you'll have to show up here. Okay? That is also when the second week of lab redos opens up. All right? That's when the second week of lab redos opens up. That is also including tests. Okay, if you've not redone whatever tests that you wanted to redo just yet. I'll be honest, as far as like redo grades, I'm behind on that. So if your overall grade hasn't been reflected from the redos that you've done so far, that's why, because I've not gone in and made sure that the new one overwrote the old one. But I'm going to try to do that tomorrow and Thursday and get caught up on that. You know how it is with spring break. And then we're also, that day, the whole class, we're going to be getting ready for the final. Okay, we're going to be reviewing for the final that day on the 24th because the final opens on the 26th, which is next Wednesday. Okay, and a couple of things. For starters, the finals are going to be online. Okay, just because, you know, I know y'all are tired of coming here. And really, you know, the week after that, I've got to get my grades in. So I figured, well, you know, we'll just go ahead and cut off the in-person meetings early, and then we'll just, you know, make the final online for everybody. And I can scramble it better than scrambled eggs, so that way, you know, nobody will be cheating. Also, for the final, there is no work entry for this because I've got a lot of grades to put in, and I've got to have my grades done by, I think, May the 4th or May the 5th. I think it's the 5th because the 4th is the last day of all the classes, but we'll be done before that. So, yeah, to get all that grading and stuff done and certifying and whatnot, I needed time to make sure I got all the redos and everything taken care of. So no work entry for the final. All right, it'll just be the answer entry part. But it's worth 200 points. Okay? Now, don't take that to think that your final is 200 questions. All right, it's not a EMT state certification test or anatomy and physiology test or anything like that. It's just, it counts more because it should. It's the final. Right, it's 200 points. So just make sure that you know that. The final will be due on May the 2nd, all right, which is a Tuesday, which is, you know, we've not really done a whole lot of that, but it's due May the 2nd by midnight, okay? Now, one thing that you guys need to know and the online folks need to know is that I always put the due dates as midnight. But sometimes Moodle does maintenance at anywhere between 10 to 11 o'clock at night. So my suggestion is don't wait until, I don't know, 11:30 on May the 2nd to turn that in, okay? You know, get it done before then, please. One last thing, there, you know, it's time for evaluations, please make sure that you get those done. That's a school thing. That's not a me thing. All right, they want those, mainly to see how I'm doing. So just make sure that you get those done. It's in your Moodle dashboard somewhere. I think there's like even an evaluations tab somewhere. I've not really looked at it a lot from the student side. So any questions about the next couple of days? Sylvie? Yeah. Oh, do you? Okay. Right. Okay. Oh, yeah. So Sylvie said that golly, it's been a Monday after spring break for sure. Sylvie said that you get an email link to your evaluations, so you can get to them that way too. All right. Anything else? When we review for the final, please make sure that you got all your stuff, your notes, anything that you got saved on your computer as far as like diagrams that we've done in Moodle, stuff like that. All right. Everybody good with this? Okay. So let's start the linear side of things with our nonlinear and linear section. This is our last regular section before we get ready for the final. I initially put that it was a short lesson, but lo and behold, the more you work on it, the longer it gets. So, but it's not bad. If you've been through high school algebra, or even like pretty much 8th grade math or whatever they call it these days, this should hopefully be a refresher for you. Okay. All right. So let's go to full screen. All right. So linear versus nonlinear functions and graphs. If you're looking in the textbook, excuse me. If you're looking in the textbook, you're going to be looking in chapters 8A, 9A, and 9B. Now, that's not in any particular order. Okay? I did kind of henpeck things from those sections to build this lesson. Because honestly, some of the ways that they did it in the textbook, especially when it gets to the nonlinear stuff, they made it a little bit more difficult than it needed to be. So we'll look at that on Wednesday. But for now, linear. All right. So how many have heard of a linear function or a linear equation or a linear graph before? Sylvie? Yeah. Okay. Yeah, everybody has. Good, good, good. So this will be a brush up then. So the root word in linear is line, right? As in straight line. So the fancy definition is when the independent variable, which is x, independent meaning that it's not relying on anything else to do what it's going to do. It might be just a given set of numbers, or it might be something that acts on its own, like temperature, time, things of that sort. Okay? And this is embedded in Moodle, by the way, if you want to pull it up on your screen. So it's when the independent variable, I wanted to talk one of these days, and the dependent variable y, dependent means that it is generated based off of what is happening to the x, to the independent variable. You don't know what y is until you figure out what happened to x. That's why it depends on what happens to x. The dependent variable, they have a functional relationship that makes a straight line when you graph it. All right? So, well, I want that back. That's one of my favorite pencils. Anyway, so it's built off the slope-intercept form. How many have heard of slope-intercept form before? All right, good deal. So slope-intercept form is, when you're first introduced to it, it's called y equals mx plus b. But if you've worked with it extensively before, you know that sometimes it's actually y equals mx minus b as well. So I've got a fix for that here in a bit. So the book talks about a linear growth rate. Okay? If something has a linear growth rate, it basically means it's changing by the same amount with each independent variable. Okay? Which means that whatever the next independent variable is, the same thing is happening to that one that has happened to the one before it and the one before it, as will happen to the one after it and the one after that. So it makes a straight line. All right. Any questions about independent and dependent variables? This isn't just a math thing. This is also a science concept. All right. If you ever had to do the science fair stuff, which I don't know if they make you guys do that anymore, but that was one of the things that they would talk about, your independent variable versus your dependent variable. Okay, slope-intercept form. Like we said, that's the model used to build a linear equation. It works like a formula. So it's not really a form like, fraction form, percent form, decimal form, so much as it is something that you can actually use to get calculations out of. All right, I call it y equals mx plus or minus b, because sometimes it's going to be plus b, sometimes it's going to be minus b. All right, and here's why. Each of these four letters, y, m, x, and b, they all represent something that you need for your graph. Okay, so let's just go left to right. Y is your output. This is where your dependent variable is found. Okay, you find y after you do everything on the right side to it. All right, m is your slope. Your slope is basically the ratio of the change in your y's, or your vertical distance, over your x, or your horizontal distance. We'll explain more about that in a minute. I kind of made that sloppy. X is your input, or your independent variable. I'm going to get that wrong. So just read what I wrote, and if I say it wrong, I apologize. But your input is your independent variable. A lot of the time, and especially when you go to do your labs here in a couple of days, it's independent because it's pretty much already been given to you. All right, it's already going to be presented. It's going to say, find the dependent variable with this function and this independent variable, or find y based off of this function with this x. All right, so there's that. There's the old saying that I used to use with my middle schoolers: x goes in, y comes out. All right, it works like a machine, and because machines have a function, this is a function. X goes in, y comes out. Now, plus or minus b, that is something called your y-intercept. Does anybody remember what the y-intercept is in terms of a graph? All right, we're going to take both of your answers and put them together because you both got part of it. It is where the line meets the y-axis. So like if you're drawing it, it's where it cuts across the y-axis. Yeah. Well, it's the whole graph, but the y-intercept is one point where it cuts across the y-axis. Yeah. So you both had part of it. Yeah. Yeah. You mean the coordinate plane? Yeah. Yeah. About you're talking about like a intersection, basically. Yeah, sort of. We're not looking at where two lines cross. We're just looking at where the line that you make, the graph that you make, cuts across the coordinate plane. Yeah. Well, it'll get clearer here in a second. Yeah. 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 Top. Y is vertical, so Y is the one that goes up and down. In fact, let me just do this. Uh-oh, I've lost my... Did I even turn the marker on? Maybe not. Maybe not. Okay. Well, all right. It did this morning. Messed up on me. Of course it would. Why doesn't anything work right anymore? All right, let's go here. All right. What? No, just go away. There we go. New glass mode. Yeah. Didn't even turn it on. I guess I was thinking it was already on from this morning, but the whole thing was working horribly this morning, and it had a restart, and I'm pretty sure that restart was just to make the PDF reader work the way it's supposed to. So, coordinate plane. All right, so you got your vertical, all right? Then you got your horizontal. All right, that's not exactly level or straight, but it doesn't matter. So here's x. X is always your horizontal coordinate. And then here's y. Y is your vertical coordinate. With x, the positive side is the right side, and the negative side is the left side. If you move to the right, it's considered a positive movement. If you move to the left, it's considered a negative movement. Y, the top is positive, and the bottom is negative. So with y, if you move up, it's positive, and if you move down, it's negative. Even if you don't move into positive or negative territory, so to speak, or like a positive or negative quadrant, anytime you move to the right, positive. Anytime you move to the left, negative. Anytime you move up, positive. Anytime you move down, negative. Yeah, like even if you're still over here, if you move to the left at all, it's still a negative movement. What did you say, Sophie? Not really. That'll just kind of be covered in the slope questions, which we'll get to that here in a little bit. Good question, though. Yeah, so coordinate plane, so y-intercept, okay? So the y-intercept, when you're graphing, your y-intercept is always your starting point. It's always the first one that you mark on the graph. Now, as far as why these aspects got these variables, I couldn't tell you. I have no idea whatsoever. I can't even make anything up. For slope, the only thing I can think of as to why it got M is what I used to tell my 8th graders. S was probably taken by speed. You know, those physics nerds, they probably took it before we could use it. And then B for y-intercept, no idea. Maybe they just needed something that was alphabetically first. Maybe. Or it may not even be that complicated. It might be B because you mark it B before you mark anything else on the graph. I don't know. I have no idea. But that's just a good way to help you remember it. Y-intercept is B because you mark it B before you do anything else on the graph. Now, to make a line, you only need 2 points. That's it. You only need a minimum of 2 points. The thing is, you start with the y-intercept because it's the most important point. It's the one you start with. And then you follow the slope to find the second point. And we'll talk more about that here in a bit. But yeah, so like if you've got a line, say, you know, it's going like that. The y-intercept is where it cuts across the y-axis. Now, there is also an x-intercept, right? And there are things that you can do with that, but not anything that we're going to do. We're not even doing everything as far as like, you know, taking 2 points and making an entire equation out of scratch, you know, making biscuits from flour. We're not even doing that because we got enough things that we got to do and we just don't have the time. But are we clear on the y-intercept now? A little bit, or at least more clear than we were? Okay. So let's press on. Let's talk about slope. All right. So slope is how the y-coordinate or the dependent variable changes in relation to how the x-coordinate or the independent variable changes. So like we said a while ago, to draw a line, you need a minimum of 2 points. Well, to find slope, you also need a minimum of 2 points. So there's not a coincidence, right? You have to have a minimum of 2 points to make a slope, and you can't make a line without the slope. So that's why you've got to have 2 points. So the formula is expressed as the change in y or if you want to write it down this way instead, the vertical change over the horizontal change. Apologize for the writing. But yeah, slope is your vertical change over your horizontal change, or your change in y over your change in x. Now, the formula for that is y2 minus y1 over x2 minus x1. The difference in your y values over the difference in your x values. Okay? Now, notice how I've got the 2 points that you need for your slope. x1, y1, x2, y2. Every point, every ordered pair is x, then y. X, then y. The most common mistake that I've seen people make when it comes to slope is that they try to do y2 minus x2 on the top, or an x2 minus, I don't know. They get them in the wrong place. The slope formula is basically substitution if you know where every part is. So that's why I always tell everybody, make sure that you label your points when you get ready to find it. So a little bit more detail about the y-intercept. The y-intercept is where the line will cross the y-axis. That's your plus or minus b part. It's the starting point of the graph. It can be positive or negative. Okay? If it says something like plus 5, that's above the x-axis. If it says minus 5 for your y-intercept, that's below the x-axis. Right? So it's a lower line as opposed to the one that I drew a while ago. All right? Any questions about the slope formula? Okay. Again, remember, if you can't read my uploaded notes from this screen, feel free to upload them. Pull them up on the screen in front of you so you might be able to see them a little better. Your computer might have better resolution than what I've got here. Whew, how are we doing on time? What time is it? Wake up, computer. All right. All right, any other questions about slope and y-intercept? All right. Well, I also said that it was supposed to be a short lesson, and then the more I worked on it, the worse it got. Yeah. So it made a liar out of me, so to speak. So yeah, sorry. That's not going to work. What? Okay. So using the functions to find y, or to find your dependent variable. Again, it's called dependent because it depends on what happens to the x variable. Catchy, right? Remember, the dumber it sounds, the more you'll remember it. Just the way it goes. Okay, so I just made up a quick little linear equation. All right, so let's just look at number 1 here. All right, we've got y equals 2x plus 4 as our function or equation, whichever way you want to think of it. Okay, so a function table has a couple of parts. Now, when you make these, when you're trying to find your ordered pairs, you don't have to have all the stuff up here that I've got. Okay, but I'll just put this up here because that's how they always looked in my public school textbooks, and it kind of shows you the organizational process. Okay, now I will tell you that these x's, I just pulled them out of thin air. Okay, in years past, I would tell my students, you know, you only really need 2 points, but they want you to find 3. So just use, -1, 0, and 1, because those are consecutive. They're in order. So you could do that if you're having to draw one. But, I mean, since you're uploading this into Moodle, I'm not going to actually have you draw one. You're just going to be reading them. You're not going to be drawing them. But I just used -2, 0, and 1. All right, I'd like to use negative so that you can see your rules for multiplying and dividing and adding and subtracting negative numbers. Okay, so this is supposed to say substitute and solve. When it copied, it's made substitute and solve. I don't really know how that happened, but we're just going to go with it anyway. So you're going to substitute in these x's into the function and find your y's, and then build an ordered pair. So first we're going to start with negative 2. Okay? So negative 2 is our first x coordinate, our first input, our first independent variable. Okay? That negative 2 is going to go in place of x. Okay? So anytime I substitute, I use parentheses so that I can see that this is something different, something new, something important that I've got to make sure I know how to deal with. So now it says y equals 2 times negative 2 plus 4. Now it's just order of operations, right? You do your multiplying, then you do your adding. So 2 times negative 2 is negative 4, and then that gets me to right here. So negative 4 plus 4, that's 0. So I've got my x coordinate, I've got my y coordinate, and now I've got my first ordered pair, right? Negative 2, 0. So, yeah. So remember, the x's are going to be given. All you have to do is find the y and then most likely put it together as an ordered pair. Okay? Do it again with 0. So 0, you know, is kind of the wrecker of all things, because anytime you multiply by 0, it's always going to be 0. And if you try to divide by 0, your calculator freezes. So, you know, it just messes things up. But 2 times 0 plus 4 is what it looks like after you substitute. Okay? 2 times 0 is, of course, just 0. 0 plus 4 is 4. So you've got 0, you've got 4. There is 0, 4. Now, somebody answer me this. Why is 0, 4 a very special ordered pair? It's on which axis? We got a 50-50 chance somebody's going to be right, somebody's going to be upset. Emma's inner contrarian came out because Sylvie said Y, and Emma's like, I think it's X. No. Okay. The rule is you have to think backwards. Okay? If there is a 0 in the X coordinate, that means it is the It's like she was at a craps table at the casino and then immediately realized she put her money on the wrong one. And she's like, no, middle. Like it's a wheel, it's not a middle. But anyway, so the coordinates are x comma y. So if you have a 0 for your x and there is a number there for your y, that means that is your y-intercept coordinate. Now every table is not going to have your y-intercept in it. Okay, this one just happened to because it had an x of 0. So if there is an x of 0, that's your y-intercept. So to answer the other part of this, the x-intercept, which we don't use a whole lot, the x-intercept has a 0 in place of y. We don't use that much though. Actually, we're not going to use it at all. Unless, of course, that's the only one that pops up. For instance, this up here is the x-intercept because a 0 showed up in the y. I didn't even design that way on purpose. That just happened. When I was making this morning, my subconscious said, we're going to make a y-intercept. And I didn't even realize I was doing it. That's a little scary. That's like some get out stuff, you know, like the small part of your brain doing stuff that you're not aware of. So then 1 goes in, 2 times 1 plus 4. So that's just 2 plus 4, which makes 6. So that's just a run-of-the-mill ordered pair. So the point of making these ordered pairs is if you had a question that said graph this line, okay? You can plot those 3 ordered pairs on a coordinate plane and get a straight line. All right? So any questions about this number 1 up here that I've kind of marked all over? Anybody still copying parts of it down? Again, are the x or y intercepts always going to show up in the tables that you make? No. They might be designed that way, but I wouldn't count on it. All right? Now, I will say this. If you look at the equation, the y-intercept has to be there. Okay? Your y-intercept is right here. That's your plus or minus b right there. Right? So the y-intercept will always be there. It may just, the x for it may just not be a given value. All right. Let's move along to the next one. We've got y equals x minus 5. Okay? This one, the x is a little bit quicker to get through because it's not being multiplied by anything except 1. And that's not going to affect it. Now, if it said negative x minus 5, then you'd have to multiply it by negative 1, which is really just aggravating more so than anything else. It's not really going to be difficult. I swear, the thermostat in here only has 2 settings. Savannah, Georgia, and Greenland. It's either burning you out of here or making it so cold that your clothes are cold. Which is what was happening to me. It's like, that's how you know when it's cold in here. But if it's just x, you just put these in place of it, run the math, get your ordered pairs, and then mark your point. So like for negative 1, that makes negative 1 minus 5, or you can think of it as negative 1 plus 5, or negative 1 plus negative 5. Do keep, change, change. Keep the negative 1, change the minus to a plus, change positive 5 to a negative. But do this instead, because this, even if you're more comfortable with writing it this way, is extra work. You don't really need to do that. Because remember, when we said that if you move to the right, it's positive, and if you move to the left, it's negative. That accounts for pluses and minuses too. So like if you have negative 1 minus 5, that means you're going to start at negative 1 on the x-axis and then pull it 5 places to the left, right? To get to negative 6, right? If you visualize a number line, that's what happened. So that makes our ordered pair negative 1, negative 6. Okay. Do the same thing with 2. 2 goes in place of x, 2 minus 5. If you're at positive 2 on a number line and you pull it 5 places to the left, where do you wind up? Well, 1, 0, negative 1, negative 2, negative 3, right? Easy. So you don't have to necessarily be skilled at adding and subtracting integers. It definitely helps. But, there's ways around it. And then 3 goes in. 3 minus 5. Well, you're at 3. Pull it 5 places to the left. 2, 1, 0, negative 1, negative 2. 5 places. There you go. All right, so there's that. Again, do you need 3 points to draw a line? How many do you need? There you go. Good. Anybody still copying this down? All right. Is it 2 o'clock yet? Is it time for a break? 1:45. Okay. We might get done before the break. Wouldn't that be nice? Okay, let me back this out a little bit. Okay. So let's talk about graphing. Now again, since your assignment is in Moodle, there's not really a way to make you draw these out. I mean, I could have you do it on the work entry, but I'm so far behind on grading, the first makeup work and the makeup tests and things that, it'll be pretty straightforward by comparison. But go back to that number 1 we did, the 2x plus 4. I'm going to show you how to draw that with the points and draw it without the points, just using the equation. Okay? So let's use the points. So for the points on that one, we got -2, 0. We got 0, 4, and 1, 6, right? So you mark all three of those. Okay, so -2, 0 means that you go out 2 to the left, -2, 2 left. 0 means that you don't go up or down because there's a 0 in the y place, right? So there's that one. Then the next one was 0, 4. 0, 4, so 0 in the x, you don't move left or right at all. 4 as in +4, so you go up 4. And there's your second one. Now, someone's going to be watching this online and think, did the tape just skip? What happened here? Okay, so the first point was -2, 0, right? So -2 in the x means that you go 2 left, right? 0 in the y means that you don't go up or down at all. So 2 left, you don't move up or down. So there's your first point, all right? 0, 4, 0 in the x means that you don't move left or right at all. And 4 in the y is a +4, so you go up 4 on the y-axis, and then there's that. 1, 6 kind of looks weird because it looks like it's more like a 2, 6 because I was in a hurry and I messed it up. But anyway, it's supposed to be over 1, up 6. So it's supposed to be like right there. There, I covered it up. Yes. Yes. Nope. Nope. It's +2. Yeah. I'm going to show you why in a minute. Right. Yeah. So you mark those 3 points. 1, 2, and then 1, 6 is about right there. I'll fix my problem there. Okay, again, do you need all 3? No. Do you need at least 2? Yes. So once you've got those 2, draw a line through it. I used a ruler to make it look better for you. Okay, so there you go. And any other point that you, or any other x that you pick off of this number line and test in that function will spit you out a y that fits on that line if you did it correctly. And that's what makes it linear. The same thing is happening to every x coordinate, every independent variable in that set of numbers. Okay? So that's if you find the points, mark them, draw it out. Now I'm going to show you how to do this without the points. Okay? So going back to the equation, you got y equals 2x plus 4, right? Where did we say the starting point was? There's 4 variables in slope-intercept form. One of them is a starting point because you mark it before all the rest of them. B, and B is the... Nope. Yep. Yeah, B is the y-intercept, okay? So look here. You've got plus 4. That's your B, okay? So you mark that first. Mark your y-intercept, okay? Then, and I'm going to switch colors for a second. Hope that shows up. Then we do something called walking the slope. And what it means is you follow the slope's directions to the next point. Here's what I mean. We know that our slope is 2 because 2 is sitting in the m place, and m is slope, right? Now, the problem here is that for equation purposes, leaving it as a 2 is perfectly fine. But for graphing, it makes a problem because slope has 2 movements, vertical and horizontal, right? Right now, there's only 1 number showing. You need 2 numbers. So if it's a whole number, you take it and put it over 1 because slope likes to be a fraction when you're graphing it. Okay? Because if you didn't have it as a fraction, here's what would happen. Okay? You would go to your y-intercept and see that that says 2, go up 2, and stop. Well, that's not going to give you a line. You'd be sitting right on the axis. There would be no line, right? Right. Yes. Okay, so that's why you don't go up 2 and stop. What you do is you go up 2. By the way, how did I know to go up 2? There we go, positive 2. And how do I know to go right 1? And they are both positive, right. If they're both positive, you're going up to the right. 9 times out of 10, the bottom will be positive. You should be moving to the right most of the time. The negative will be at the top. So the only difference is, are you going up or are you going down? But you should still be moving to the right. Make it easy on yourself. All right. Now, look at those two graphs. Did they both cross at 0, 4? Do they both have the point 1, 6? Yeah. Okay. So my suggestion is, if it doesn't specifically say make a set of points and graph them, or a more likely situation, pull 3 points off of this pre-made graph, and if it says something like what are the slope and intercept off of this graph, then you'll be okay. All right. Using the slope and the intercept is a lot faster than doing the points. But see, here is the catch. Okay? This one, using the points, is easier but slower. Using the equation is faster, but it's advanced. Okay? Because you're not making points, you're just using the equation. It's a higher level of thinking. Okay? So my suggestion is, kind of get good at both. All right? All right. Questions about graphing using the points or graphing using the equation? Who's still copying that down? I'll give you a minute. Yeah, thank you. Remember that when you're graphing with the equation, you always start with the y-intercept. And as far as we know, they labeled the y-intercept B so that you would mark it B for anything else. I really hope somebody writes that down. B for anything else. All right. Is everybody good with this, or anybody still copying this down? Everybody good? Okay. So let's flip it around. Let's look at what would happen if you have to read a pre-made graph. This is more likely what you're going to be seeing. I got tongue-tied there. What you're going to be seeing on your Moodle labs. All right? Because it's easier for you to read a graph and pull the stuff off of it than me to try to look at one that you've made by hand and figure out if the point's in the right place. All right? So I just took a graph and just made one up. All right? So when you're reading graphs, the steps are still the same as if you were graphing using the equation. Okay? So reading a graph and graphing using the equation, the steps are basically the same. There's just a third one that we'll talk about here shortly, and it's not hard at all. All right? So the first thing you do, in this case, instead of marking the y-intercept, oops, I do that every class period. Instead of marking the y-intercept, you're going to find it. All right, it's already been marked. You just have to find it. Okay, so on this graph, the y-intercept, as you can see, is right here. Well, I kind of obliterated it. But the y-intercept is right here at 4. And that is a positive 4, right? Okay, so the y-intercept is at 4. So there's part of it. There's your first part, okay? The second thing you do is you find the slope by walking to the next point, okay? Now, if you look at this graph, the positive ones that we did, the two positive ones, they were both leaning to the right, weren't they? They were leaning towards the positive side of x, right? This one is leaning towards the negative side of x, isn't it? So this one is a negative graph. Positive graphs have a positive slope. So negative graphs have a negative slope. There we go. Somebody asked about that earlier, so here's where it shows up. So find the slope by walking to the next point. So what I'm going to do is I'm going to start at the highest point and move down to where I'm level with the lower one, okay? If it's a positive graph, I'm going to start at the bottom and work my way up. So if it's like, let me just do this, just to clarify. So like these here, like on this one, that one there, we started at the bottom and went up. So for a positive one, my voice went away. For a positive one, start at the bottom and go up. But for a negative one, start at the top. Shoot, I just made a big swarp right through the middle of that. Start at the top and go down. All right. The reason for that is because you're finding your vertical change first. And the reason why you're finding your vertical change first is because that goes in the top of your slope. Okay? So, we go down 1, 2, and we get level with the point, right? And so I wrote that right here. M equals down 2, and then after I went down 2, I went right 2. Okay? Down 2 and right 2. When you move down on a coordinate plane, remember, when you move down, you're going in a negative direction, right? Now, somebody asked this earlier. What if you don't move into negative territory? Still the case, okay? We didn't move into negative territory here, did we? No. Vertically, we're still on the positive side of things. But when you move down, it's a negative movement, so that's why it is negative 2. And then we moved to the right 2, so that is a positive 2. So now we're here, okay? Negative 2 over positive 2. Slope does like to be a fraction, but it also likes to be a simplified fraction. So simplify that to negative 1 over 1, or in this case, oops, that needs a negative there. I already had to fix this once. Oops. I'll fix it and upload it again. All right. So negative 1 over 1 or just negative 1. Remember, for a graph, you need negative 1 over 1. For an equation, you can just use negative 1. Now, if it's anything but 1 in the bottom, like if this had said negative 2/3, you're stuck with it. You have to use that whole thing. Okay? And most of the time, your slope may be a fraction. Just be ready for that. Okay, so then you build the equation. So when you build the equation, m equals negative 1. Your b is a positive 4, or in this case, a plus 4. So put it into the y equals mx plus b format. Mx plus or minus b format. Negative 1 goes in for m. Plus 4 goes in for the plus or minus b. Now, you could leave it as negative 1x plus 4. I'd be fine with that. Okay, that doesn't bother me in the least. But as far as like our materials, our books and things, they would like you to simplify that to just say negative x plus 4. And then you're done with that one. All right? And we'll break there for 10 minutes. Then we'll come back and finish up with some more stuff on slope. Okay, so last thing that we're going to look at today is probably something that we should have looked at earlier on, but, you know, better late than never, they say. Finding slope from 2 points. Okay, like I said, the hardest thing that I could make y'all do is take 2 points and find every aspect of it. The slope, there's even a thing called point slope form, which generates the y-intercept for you. I'm not going to make you do all that. We've gone through enough. But we do need to know how to find the slope if they're going to give us 2 points, because they are. They're just going to give you 2 points, and they're going to say which one is the slope. All right, so the slope formula we mentioned earlier is m equals y2 minus y1 over x2 minus x1. Or think of it as, find my little board pen here, think of it as the change or difference in y, or, you know, your vertical change over your change in x, or your horizontal change. All right? It's always going to be your vertical over your horizontal. That's why whenever you are reading a graph, you find your vertical movement first, because that's always in the top of the slope. Okay? So we've got 2 points here, 0, 5, and 6, negative 3. Okay? Again, quick quiz. What is significant about 0, 5? It's on, yeah, that point is on the y-axis. It's the y-intercept. Yeah. If it has a 0 for x, correct. That is the y-intercept. Yeah. 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 If it has a 0 for x, that is your y-intercept. Not really significant as far as what we're doing right now, but it helps to know that if you need the point of the y-intercept, it's going to have a 0 for x. Okay. So 0, 5, that is my x1 and y1. It is not x1 and x2. That's the most common mistake I've seen people make, is thinking that in the first set of parentheses is both your x's, and in the second set is both your y's. That is not true. Each pair has one x and one y. This one is called x1 and y1 because it is your first ordered pair. This one is called x2 and y2 because it's your second ordered pair. Okay? It helps me to label the bottom of them. So if it helps me, I figure it would help you too. Okay? Because if I label the bottom of them, all 4 of those are now separate variables, and I know where they go in the formula. Right? So the formula says m equals y2 minus y1 over x2 minus x1. I've always said it for years, the best way to learn a formula is to write it down with each new problem. Okay? So, n equals y2 minus y1 over x2 minus x1. Plug them in. So, negative 3 is y2, right? So, that's going to go in place of y2. So, you're going to start with negative 3 right here. Then, we're going to subtract 5. y2 minus y1, y2 minus y1, right? So the top is going to say negative 3 minus 5. So we got that part covered. Let's do the bottom before we go anywhere else. The bottom is x2 minus x1, right? 6 is x2, 0 is x1. So that's why the bottom says 6 minus 0. Okay? Now, do your math, do your operation. All right, you're at negative 3 on the number line. You're going to pull it 5 more spaces to the left. You're going to wind up at negative 8, right? 4, 5, 6, 7, 8 to the left. There you go. So negative 8 in the top, 6 minus 0, well, that's just going to be 6. Now, we said that even though slope, likes to be a fraction when you're graphing it. It does like to be a simplified fraction. So negative 8 over 6 becomes negative 4 over 3. Now, what this means, if you were graphing this with a y-intercept, it means that whatever that y-intercept was, your next point is down 4 spaces and right 3 spaces from the y-intercept. All right? So any questions about the slope formula? Again, let me clear this out here. So y2 minus y1, negative 3 minus 5, x2 minus x1, 6 minus 0. Do your adding and subtracting of integers. You get negative 8 over 6. Don't divide that. Reduce that to negative 4 over 3. All right. Any questions about number 4 here? All right, let's do one more. Let's look at number 5. All right. Number 5, we've got 2, negative 3 as our first ordered pair and 4, 1 as our second ordered pair. Remember, you are going to have questions on your lab that say, here's this point, here's that point, find the slope. Okay? So, when you have to find the slope, always write down the slope formula. M equals, about messed up there. M equals y2 minus y1 over x2 minus x1. So that's going to be, 1 minus negative 3. It'll be really easy to mistake this and make it say 1 minus 3 because of that negative 3. It's 1 minus negative 3. Now, if you need to, use that old trick of keep, change, change to simplify this. Keep the 1, change the minus to a plus, change the negative to a positive. That way, instead of 1 minus negative 3, you're looking at 1 plus 3. That's a lot easier to deal with. Then the bottom, x2 minus x1, that's going to be 4 minus 2, and that's easy to deal with also. So the top, 1 plus 3 to make 4. The bottom, 4 minus 2 to make 2. That's 4 over 2, which reduces to a 2 over 1 or a 2. Now remember, with whole numbers, or anything over a 1, if you're graphing it, use the fraction. If you're graphing it, use the fraction. If you're building an equation, you can remove the 1. All right? So there's a couple of examples with slope. So on Wednesday, when we come back, we're going to be looking at the nonlinear sides of things. Okay? We're going to be, if you've already gotten it, or if you haven't gotten it, or know somebody that's gotten it and you want to borrow it, a lot of the stuff for this section came out of here. The everything you need to ace math in one big fat notebook. I know I put this as supplemental in my 110. I can't remember if I put it in for the, I think I did. Okay, yeah, because this is just too good not to put in. Ignore the fact that it says middle school. Okay, it still applies. There's stuff I used in here for when I had the support classes in Swanson taught 143. All right. So use this. I leaned heavily on this for the nonlinear part as well. So you can use that. I'm going to be, throughout the course of the day tomorrow, I'll be uploading some pictures and scans I took out of that book and its companion workbook and uploading it into this section of Moodle so you'll have it as well. Because it's just organized pretty neat and it's all colorful and stuff. Not like me. So, any other questions about the linear part of this? Okay, see you on Wednesday. Thank you, my favorite pencil.